here I explain selected questions. After the class, I will post the solution file. Yeah, so some questions relatively easy, you just study the solution file. Yeah. For questions relatively harder, so I explain here. Okay. All right. Yeah. So the first question, a lot of problems. Yeah. The main problem is here. First, you need to use the Horner's rule. Yeah. Second, the idea, reuse the resource, that idea, you need to explore, to the extreme, try to do a very good job to save multiplications. Yeah. All right, so let me explain that. Yeah, so definitely the Horner's rule. Yeah. Actually, for the Horner's rule, not just the result, because here this question I modified slightly different from the typical situation of the Horner's rule. So you need to go back to our factorization formula for the Horner's rule. You need to go to that step. Yeah. So do you still remember how do we do the factorization Horner's rule? Yeah. So here let me write that factorization explicitly. First factorization, x cubed. You factor it out inside parenthesis a1, then x to the fourth. Yeah. This place slightly different from our original Horner's rule because the power function x cubed is different from the power function x to the fourth. Yeah. That's slightly different. Yeah. All right. So then a2 another x to the fourth, a3 plus x to the fourth. This is the factorization. You need to work on this formula. Okay, the first step. If you do not get this formula, then I saw some students just count the number of multiplications directly, term by term, in that way, because you didn't share the multiplication. This way, we share multiplications among different terms, so we can save a lot. Yeah. If you do not share multiplications among different terms, you use more than necessary multiplications. Yeah. All right. Now, before we do the counting, here you can see we need to get x cubed first, then x to the fourth. So you need to do preparation. The preparation step, you need to calculate x cubed and x to the fourth. So you calculate them together because in your calculation, you need to share resource. In the calculation of these two numbers, try to share your resource as much as you can. Okay? Yeah. If you calculate separately, you may not share the resource. Yeah. You may do the redundant calculation. Then you waste one or two multiplications. So here, share the resource in your calculation. All right, yeah, so. All right. Yeah, although there are many ways, yeah, but here it's pretty simple. So you can, for example, you can use this way. X cubed, you can write x squared times x. Yeah. So you need two multiplications. X squared one, then another one. But x to the fourth, do not recalculate x squared. You already have x squared. So you should reuse your x squared number. Okay? All right. So x squared, another square. That means you just need one more multiplication. Yeah. So the total in your preparation step, you need 3 multiplications. That's preparation. All right. Then, after preparation, now you can count. You go back to this factorization formula. You can do the counting. Okay? Yeah. Counting at each parenthesis, that place, there is one multiplication. X cubed, you already have that number, you just use it. So another one here, between x to the fourth and the second parenthesis, another multiplication. Third and fourth. Yeah. All right, so 4, add 4. So your total, 3 plus 4 equals 7 multiplications. So your answer is C, 7. Okay? Yeah. 7. Yeah. Many students give me 8 or more because you count more than necessary, right? Yeah. So for many different reasons, you count more than necessary. All right? Yeah. So I'll give you a partial credit. Yeah. So for 8 or more, you get 2 points. 2 out of 4 points. Partial credit. Okay? Yeah. And try to understand. Yeah. So the idea. All right? Yeah. So in the midterm, I will give you a similar question, definitely. All right? Yeah. But I'm modified slightly. But you need to understand the solution completely. Then you know how to modify. Okay? Yeah. And this formula, writing in this way, you have to use it. This is the key step. Writing the formula in this special factorizations, this is the key step. Okay? Yeah. Then I modify a few places. Question, Chelsea?
So I see the 3 multiplications to get the x's, and then I also see 3 multiplications in the problem where you got the first parentheses
Right.
times x to the fourth, and then you compute everything, and then the next parentheses times x to the fourth, and then the next parentheses times x to the third.
Right. Right.
And so I see those 3 multiplications.
Do you see one here? Do you see one here? Although no parentheses, but there is one coefficient, right? Yeah,
Okay,
yeah. So the arrow place, all right? So I put the arrow. Yeah, I saw, some students missed this one. Yeah. So you lost 1 point, okay? So if a student just missed that one, so 1 point, yeah. But I have to see you write out the formula. I need to see you, if you put this formula on paper, so then you lost 1 point, okay? Yeah. If you do not, lost 2 points, okay? Yeah. Because I don't know. How did you get that? Okay, if you give me more information, you can earn a little more partial credit. Okay, yeah. All right, any other question? Yeah. Yeah, remember this question? You will see similar question again in the midterm, but I modify slightly. All right? Yeah. The part I modify, power of x related to the power of x. I modify that part. Okay? Yeah. But you need to stick to that, our basic idea. Share the resource, that idea. Okay? How to save your multiplication by minimize your redundant computation. Avoid. If it's possible, you avoid redundant computation. Okay? Yeah. All right. Yeah. Second one, yeah, this question, there is some problem. Yeah, there is some problem. So if you answer both A or B, so I give you, I treat both correct. Yeah. So why there is some problem? Yeah. So one student pointed it out. One student solved this problem. Yeah. So I give that student 1 bonus point. Yeah. So the problem is, there is a special case. Yeah. In my original thinking, it is true, yeah, but there is an exception. There is some exception case. Yeah. All right. For the general case, it's true, but there is one exceptional case. It's false. Okay? Yeah. So for that reason, no matter you answer A or B, so I treat both correct. Okay? All right. So the problem is this. Yeah. First, let me talk about the general case. General case. Okay? Yeah. Suppose we have, many n elements. Okay? Yeah. Position 1, position 2, last position. All right. Only 2 elements are in place, remaining not in place. That's the requirement. Okay? Only elements in place. Let's assume the first 2 elements in place. Then we want to make the remaining elements in place. Okay? Then we can use, remember we have a previous question. Previous question, we make all elements not in place. So we use that idea. So we do rotations. We do a rotation. Okay. So we move. Suppose we start from all elements in place. Then we move. In this way. Rotation. Okay. Yeah. Then, other than the first 2 elements, all the other elements are not in place. So this is the idea for the general case. But there is a special case. You cannot do rotation because other than the first 2 elements, you only have 1 element left. You cannot move. Okay. So when n equal 3, yeah. So if you fix first 2, only 1 left. 1 left. It is the third one is forced to be in place. Then it's not true. Right? Yeah. So if the question, if I give you greater than 3, so if I change this number greater than 3, yeah, then no problem. Yeah. No hole. Okay? Yeah. So you can do the rotation. You can always do the rotation. Okay? Yeah. things like that. Okay, yeah. So that's the main problem. Yeah. 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 So I didn't know this problem. Yeah. So that student pointed out. Yeah. Yeah. So I give him 1 bonus point. Yeah. All right. Yeah. All right. This one, yeah. This one, yeah. Many of you, so I know you try very hard, yeah, all different ways. Yeah. But here, the best solution is 9 multiplications. Yeah. From what I saw, most of you, the best you can get 10 multiplications. Yeah. But here, there is a way you can get 9 multiplications. Let me show you how. Yeah. So here, when you do that, you need to, first you need to do experiments. Then you need to try to, when you do experiments, you need to do a lot of analysis work. Yeah. Yeah. Try to take advantage of the special structure and save the all right, so here, the structure, yeah. 147. How do we decompose it? There are many different ways, right? Many different ways. Yeah. Yeah. So here, one way, can you see it's a multiple of 3? Can you see multiple of 3? Yeah. You can see it's a multiple of 7, right? Yeah. 7 times 21, right? 21 is a multiple of 3, right? So 21, 3 times 7 times 7 squared. Okay? Yeah. 3 times 49. Yeah. First step, you see that. Because if it's a multiple of 3, one natural way, cube operation. So x to the 147 equals x to the 49 to the 49 right? Yeah. So this decomposition. Yeah. Then 49. So you try 49. Yeah. So 49 actually many different ways, right? 49 many different ways. Yeah. 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 So you may like, compare repeated squaring, repeated cubing. Yeah, typically these 2 ways. Yeah. All right. So here, if repeated squaring, yeah, so let me write here. Repeated squaring. Right? Yeah. Because we need to calculate x squared 4th (32), right? Yeah. In order to get x to the 49, this step you need 5 multiplications. Okay, all right. Then 49, 32, 8, 40, right? Okay. 16, oh yeah, 16 better, right? Going faster. 48. X. All right, so 2 more. Yeah, so here you can get 9, right? So this one, 2 more. Yeah. So 5 plus 2 plus 2. So this one. So 5 plus 2 plus 2 equals 9. Yeah. Right. But another way, repeated cubing, you can also get the same result, you know, same number of multiplication. Cubing. Because 49 equals 1 plus 48. 48 equals 3 times 16. Okay, all right. 16, you need 4 multiplications. X squared four multiplications here. All right, yeah. Then we can write x to the 49. X times x to the 16, x to the 16, x to the 16. Okay, all right. So 3 more. 4, 3 more, 7 plus 2 more. Yeah, so this method. 4 plus 3 plus 2, also 9. So these 2 ways, with repeated squaring, repeated cubing, these 2 ways, you can get 9 multiplications. Yeah. But most of you got a 10, and some got a 11. Yeah. The closer. Yeah. So if you got a 10, you got 2 points, 2 out of 4. If you got 11, 1 point. If more than 11, no point. Yeah. Okay, yeah. Partial credit. Yeah. All right, so that's this question. Yeah, so midterm, similar question. You can expect. Okay, yeah. So try, yeah. Although we know there are so many different ways, but at least you need to try repeated squaring and repeated cubing. Okay? Yeah. Try your best to get the smallest number. Yeah. Okay, yeah. And another thing, yeah, although here I put this answer, if you give me correct answer, you can get a full credit, but I encourage you to put some work, related work, to earn partial credit as much as you can. Yeah, because if your answer is not correct, I look at your work. If your work is related, you know, at least give me some right direction to the solution, then I can give you a partial credit. Okay? Yeah. 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 Because you have some space, so you can put some related work. Okay? Yeah. This one, the correct answer is 10 multiplications. 10. Yeah. But most of you gave me more than that one. Okay? Most of you give me more than that one. Yeah. So let me write. So here, this kind of thing, you need some experience. Yeah. But at the same time, you need to understand the structure better. Yeah. So, yeah. All right. So this one, we need to write the original expression. Yeah. The first step, I do one factorization. I factorize x to the 46, 1 plus x to the, because in next step, so here, to solve a problem like this, you need to have good understanding on the questions of this type. You need to have good understanding. Yeah. How to save your number of multiplications as much as you can. That's your goal, right? How to save. Yeah. So here, when we factorize that x to the 46, that power function out, all right, the remaining part, we want to reuse the resource. Still that idea, reuse the resource. Yeah. Since out of the parentheses, you need to calculate x to the 46, that power function anyway, right? Yeah. You need to do that calculation anyway. Yeah. So you spend your resources, your multiplication resources, to calculate x to the 46th anyway. So you, inside parentheses, you should reuse it as much as you can. Okay, don't waste that resource. That's why we should write x to the 46 another time. Then you have x to the 5th extra. Okay, here, reflect, reuse the resource idea, right? Yeah. Because you spend many multiplications to calculate x to the 46th power, so you should reuse it as much as you can. That's why we put it here. That means this, at least the inner x to the 46th, we do not need to recalculate it, right? We just copy that number. That can save us a lot, right? Yeah. Save us something at least. Yeah. Then, after that, x to the 5th. That means you need to calculate x to the 5th. You need to calculate that. Okay? Yeah. All right. So yeah, let's calculate it first because it's so simple. Let's calculate it, right? X to the 5th. X times x squared, that's x to the 4th, times x. So this one, you need 3 multiplications. Right? Yeah. After that, now you have x to the 5th. That's your resource. You need to reuse it as much as you can, right? X to the 5th. Yeah. All right. So let's use this. X to the 15, that cube operation. Two more multiplications. All right, yep. Then another cube operation. 2 more. The last one, 46. One more. and this place 2 more. Right? 2 more. 1 here, 1 here. Okay? 2 more. All right? Yeah. So now your total. 3 plus 2 plus 2 plus 1 plus 2. 5, 10. Right? 10 multiplications. Okay? Yeah. Those students who got 11 already pretty good, very close to this number. So I believe they paid a lot of effort to get that 11 multiplications. Yeah. But here you can see, because you can see each step we try to use our understanding to guide us, to get the best solution. That process, that problem solving process. If you do experiments randomly without any logical reasoning, so then you may not get the best solution. So your understanding, you stick to that principle, reuse the resource principle. That's your principle. You stick to it. Reuse the resource. Yeah. But how to reuse, so here you can see, yeah. When we get x to the 46, we should reuse it, right? Yeah. Outside, inside. Yeah. Then you see x to the 5th. You need to calculate it first, right? After that, you should reuse it. Okay? Yeah. And fortunately, the structure, the number, that structure allows us to take advantage of, x to the 5th. That one. Yeah, not wasted. Yeah. All right, yeah. So you get more experience. From this example, you get more experience. How to minimize number of multiplications. Yeah. All right, yeah. This one, in our exercise question set, we had a similar question. Yeah, so I saw some students, put some work. I look at the work. Yeah, the first half, based on our exercise question example, but the second half, because I modified, right? I changed the exponent numbers. Then they missed that part. So only got 2 points. Yeah, many students did like that. Yeah, let me show you. The first half, second half. First half, Horner's rule. That's easy, Horner's rule. Yeah, so let's do the first half. By Horner's rule, yeah, so we have 3 pairs of parentheses. Let's calculate. Yeah. 3 pairs parentheses first. Yeah. The first pair of parentheses, U equals two multiplications. All right? Yeah. U, this is U. Okay, we use a variable. Because we don't want to copy this long formula many times. Later, we just use UVW, short notations. V, B0 plus B1 X 1 multiplication. All right. Third pair of parentheses W, C0 also 2 multiplications. All right, yeah. So the first step. Yeah. So you get 2 points. Okay. Yeah. If we apply Horner's rule to get these numbers, you get a 2 out of 4. But the second half, then you need to do something special. Still, we use the resource idea, but the reuse the resource idea here, we need to, because that's the high level principle, right? The top level principle. Regarding this question, we need to get a more specific strategy here. Okay? From the higher level, move down. Yeah, more specific. That's shared squares. Okay? All right? So here, let me write the main idea here. Okay? Still, we use the resource by sharing the squares, square operations as much as, yeah. Because here you can see the exponent number 2, 4, 8. That means there are many square operations. When you do square operation, I look at those students, they do squaring operations separately. They didn't share squares. That's the reason they use more than necessary number of multiplications. Here, you need to share square operations. So let me show you how to share. Okay? All right. The way to share the squares similar to the way we share multiplications in Horner's rule. Do factorization or in Horner's rule. Here, the square operation, we do a similar type of factorization. Still factorization, yeah, but the factorization with respect to the exponent numbers, that kind of factorization. Okay, yeah, let me write the factorization formula. P of x. Before factorization, we write u square v to the 4th w to the 8th. That's before the square sharing. Then let's do the first round square. We need to do several rounds square sharing. First round. Because all these exponent numbers are even numbers, right? Even numbers. Yeah. So even numbers means we can put a outside square inside a u times v square times w to the 4th. Outside there is a square, right? That means the outside square is shared by everything inside, right? That's the first round sharing. Then inside, because this u, the exponent is 1, you cannot do more square sharing, right? So you single it out, okay? Yeah, you single that u out. Yeah. The remaining v exponent 2, W exponent 4, they can share another square operation, right? Yeah. So let's write another level. U times V times W squared, these two, they can share one square, okay? Then outside square. Okay. So if you write the decomposition structure like this, then you can see, you can save several square operations. You can save some multiplications. Yeah. All right, so now let's count. How many multiplications do we need in this structure, in this last structure? Okay, all right. One here, second one here. Square is 1, right? Yeah, square, you need to do one. This square, you need to do one multiplication. This square, you need to do multiplication. There are 5 arrows, okay? 1, 2, 3, 4, 5. So this give you, okay, 5 more. Okay, all right, so count. The preparation part, you need 5 multiplications, right? Then square sharing part, another 5, okay? So total 5 plus 5, 10 multiplications. Okay? Yeah. The second half, most of you didn't do well, the second half. Sharing the resource, but that's the top level principle, still a little far away from the specific method we need to use. So we need to, move down, make it more specific. So how to make it more specific? Sharing the squares. That's the way we make it more specific. Okay? Yeah. Because that idea, we borrow it from our Horner's rule experience, sharing multiplications by factorization. Yeah. That's our old experience. But here we need to modify it. Okay? So many times you have the experience, but not quite the same, may not be used in our current situation. You have to make adaptation. Okay? You have to make suitable adaptation, like we did here. Yeah. Based on your understanding. Yeah. So that's why I emphasize understanding is so important. You need to understand the question well, the background, the goal, all those things. Then you can do a good job. Yeah. All right. Any question? Yeah. All right. Number 23. Yeah. Yeah. So this one, I look at the solutions. Many of you, the solutions, the order to arrange your comparisons, not, order is not right. Order is important here. So if you change the order slightly, the result is quite different. So, all right, so here. The given condition, this given condition, x7 is not equal to the max So we need to use this condition. Yeah, very important. Yeah. All right. But for the first comparison, yeah, some students, when they do the first comparison, they first pick arbitrary element other than this x7, then do comparison with this one. Yeah. If you do in that way, yeah, that's not the best you can do. Not the best you can do. Yeah. Because in first comparison, you use that element to compare with this one. You have two cases, greater, less than, two cases. Yeah. So that comparison actually make restriction on your result. That's not good. Yeah. So your first comparison should be, you compare two elements other than x7. Because in that way, one is greater, one is smaller. Yeah. Either case, you do not touch x to the 7. Yeah. So there is no restriction. Okay? Yeah. So that way is better than the first way. The first way because you have some limitation, restriction. Yeah. All right. So the first comparison. Yeah. Oh, what's that? First comparison. Okay. Yeah. Let's use x1 and x2. All right. Yeah. Here, compare x1 and x2. We know one is greater, one is smaller. Here, do we assume distinct? Yeah, we assume distinct. Yeah. Yeah. For a question like this, yeah, sometimes I forgot to put that condition, but you can assume we work on distinct elements. Yeah. All right. To make the discussion easier. Yeah. All right. So x1 is greater than x2, or x2 is greater than x1. So you have two cases, but here we want to simplify these two cases because these two cases symmetric, right? Symmetric means if you swap x1, x2, you get the same situation. So because the cases is symmetric, so if you switch these two elements, the situation essentially the same. There is no change for the situation. Okay? So for the symmetric case, you can assume one is greater than the other. Okay? Yeah. So all right. We make this assumption, usually we say without loss of generality. Okay? Yeah. Yeah, because if you assume the other way around, same thing. Yeah. So usually, in math, people say without loss of generality. So you can make that assumption. Yeah. But it should be for the symmetric case, right? Sometimes if you switch, it's different. Then you need to discuss each of the two cases. We have some cases that are not symmetric, so you cannot make that assumption. Yeah. Yeah. So that's the first step. All right. Yeah. Then the second step, second comparison, because the first comparison, the result could be useful when you do the second comparison related to X7. That's the reason. The first comparison, we should not touch X7. Because we need to wait, we need to delay, we need to wait to get more information before we can touch that X7, that element, that key element. That's the key element. So the key element, we want to delay process that. We need to collect some useful information before we touch that key element, X7. That's the main idea. All right, yeah. So the second comparison. Now, after this assumption, we can pick the smaller one or the larger one to do comparison, because we only have one comparison left, right? Because our goal is two comparison. We do not have too many comparison we can waste. So we only have last chance. So last chance you should use in the most efficient way. Okay? So you pick either the smaller one or the larger one, but you only have one chance to pick. You cannot pick both cases. Okay. So the second comparison. All right. Yeah. Here, let's pick the smaller one, X1 and X7. Yeah. If it does not work, we switch to X2. Yeah. Because that's the only two possibilities we can try. Compare X1 and X7. Yeah. All right. Subcase 1. If X1 less than X7. Conclusion. We can make conclusion. Okay. X7 is the solution. Because we have X1 less than X7 less than max, right? The given condition not equal to max, that means less than max. Okay? Solution. That's subcase 1. Case 1. Case 2, if X1 greater than X7. Then X7 less than X1 less than X2, right? Inherit from the first comparison. X1 less than X2. So X1 is the solution, right? It's greater than X7, it cannot be the minimum. Less than X2, it cannot be the maximum. So the second case, X1 is the solution. See? So then we find a solution. I saw one student give me a few cases, but those cases did not cover all the cases, only part of the cases. Yeah, so some students. Yeah. The reason they compare element with X7 first. The reason is that they compare element with our key element first. The order is wrong. Okay? If you do that comparison, you cannot cover all the cases. Okay? Yeah. There is one small case cannot be covered. So that's not a complete solution. Here, we compare two elements other than our critical one. X7 that's the main key element. So we delay working with X7. That way, we can get more useful information. Because if the first comparison you work with X7, because in the first comparison you do not have any useful information, right? So actually you waste your energy when you work with the critical element. You do not have a lot of useful information. You didn't take advantage of the main property from X7. Yeah. So this property, it's hard to use. Yeah. Or you did not use in the full scale. Okay, you use partially. All right. So this critical information you use partially, yeah. Not in full scale. That's the reason. That's the reason. If you use the wrong order, you cannot do the best. You cannot do the best. Try to think about, okay? So that's why we do first comparison, nothing to do with X7, because we want to get more useful information, okay? Yeah. Then, in our second, the precious comparison, all right? Because we already have some useful information, so we can take advantage of this critical information as much as possible. That's why we can do better. We can do better because we know more, right? When we do the last critical comparison, we have more information, we can do more. Yeah, that's the point. Jacob? Yeah.
I don't want to take up all the class's time on this question.
Yeah,
Do you have time immediately after class, or should I?
Yeah.
Because I have
Yeah.
questions more
Right,
about
right.
this, but I don't want
Good.
to take all the time.
Ask me after class. Yeah, after class. Yeah, let me look at my time. All right, 15 minutes. Yeah, I spent a lot of time here. Yeah, yeah, it's okay. Yeah, I try to complete. Yeah, all right. Yeah, we have 2 more left. All right. Yeah, all right. So this one actually. So I designed this question. We use actually everybody knows what result we should use, right? So we have this result. Find both maximum and minimum. All right? Yeah. So we all know we need to use this result. But how to use it, then that's important. Yeah. Yeah. I saw most of the students, they just apply this result on this n equal to 120 directly. There is a formula, right? Yeah. 3/2 n minus 2. Yeah. Yeah. That formula. They plug in that formula. Most students did in that way, then you can only get 2 points. Yeah, because you can do much better than that. You can do much better than that. All right? Yeah. So why? All right. Look at determine 10 elements in this array, neither maximum nor minimum. We only need 10 elements. So if you plug into that formula, then you do too many comparisons. More than necessary. Right? So we want to do only the necessary comparison. Not more than necessary. Yeah. So here you get the point. More than necessary. Because our goal, we only need to find 10 elements, not the maximum and the minimum. If you plug in the formula, actually you get 118. If you plug in directly, you get 118 elements. Not in max and min and max, right? You get 118 elements, but our goal, we only want to get 10 elements. not belong, not in max and min. Yeah. Look at these two numbers. Big difference. If you plug in the formula directly, you do too much redundant work, too much unnecessary work. Yeah, here, not redundant, unnecessary work, more than necessary. Yeah. So you waste your resource too much. Okay, yeah. So that you need to change your idea like this. Select arbitrary elements. You just select 12 elements. And after find maximum and minimum. Yeah, a few students, they did the right way in these 12 elements. Okay. In this way, yeah, you throw away maximum and minimum in this small 12 elements group. The remaining 10 satisfy the requirement, right? Yeah. In this way, you apply the formula. Remember, our formula is this. You apply this formula, but this time your n equals 12, not 120. That's a big difference. So you can save a lot of comparisons in this way. Yep. Several students did the correct way.
So that formula you have numbers to that's the number of comparisons on the math and
Same time. Same time, but n must be even number. All number, the formula is slightly different. Here, even. So you can use this formula. In class, I only talk about even. I left all the case to you. So if you see all the case, we have a 5, right? All the 5. Yeah. So that's the other case. All right, yeah, so we complete this one. Then the last one, oh, sorry. Yeah, so let me see how, yeah, I only have 7 minutes. Yeah. Last one, elimination method. Yeah. Although you know elimination method, but the problem is most students, I look at the solution, most students couldn't get it. Yeah, how to eliminate as many elements as possible. Here, I show you how to apply the elimination method. So here you can see for the elimination method, even if you know you should use it, but how to use it still, it's a big problem. How to use elimination method still, not easy. Yeah. All right, so here, remember, the median, if you count from left side, it's 6th smallest. If you count from the right side, also 6th largest. Yeah. Based on this fact, this basic fact, yeah, let's do the elimination twice, from left-hand side, then from the right-hand side. Now, first, we can see this. A1, A2, A3, these 3 elements. Yeah, so we use a simple way to write inequality. First, these three should be less than A4, A5, A6, right? Yeah. And the B part, yeah, because we know B3 less than A3 less than B3. So B3, B4, B5. Yeah, so you can see these three elements, they all less than at least 6 elements. How about that? At least 6 elements. Yeah. Then, based on our understanding of the median, they cannot be the median, right? Cannot be the median. That means these 3 elements can be eliminated. Can be eliminated. Gone. Okay? All right. Then, from the other side, B4 and a B5 greater than B1, B2, B3. Now A, we know B3 greater than A3, right? A1, 2, 3. A1, A2, A3. So these 2 elements greater than at least 6 elements. Yeah? Then if we look at from the left-hand side, these 2 elements cannot be the median. The median because it's the 6th smallest. Now these 2 greater than at least the 6. It cannot be the 6th smallest. None of the element in this group can be the median. So we do another round elimination. Right? So after the elimination, remaining. Yeah. So these elements remaining elements A4, A5, A6, and the B1, B2, B3. All right, yeah. These 6 elements. And we need to find, because we will look at. All right. Original median, 6th from left-hand side, also 6th from the right-hand side. All right. But when we do elimination, we eliminate 3 from the left-hand side, all right? And then we eliminate 2 from the right-hand side, okay? It will remain 3, so that means there are 3 here and 4 here, all right? So that means in this 6-element group, the median, we need to update the median. Median should be 3rd smallest, but the 4th largest. Okay, update. All right. Then, this is before we do any comparison, right? This is before we do any comparison. All right, yeah. So the first comparison, because this time you have 2 ordered arrays, x4, x5, x6, second, b1, b2, b3. So your first comparison, compare elements in the middle. Okay? Take the first element in the middle of the first ordered array. element in the middle of the second order, that's your first comparison. Then to elimination. Okay? So detail in my solution because we run out of time. Okay? Here we don't have time. But I wrote a full solution in our solution 5. I will post this afternoon. Okay? Yeah. The idea is this. Okay? Here I give you the main direction to go. Follow this direction. First round elimination, second round, third. After every comparison, you eliminate as many elements as possible and update your median position. Then do more elimination and so on. Okay? Yeah. So the remaining, read the solution. All right, that's it. So then use this weekend to do the preparation. I post the solution file, so you then study, then quiz 1, 2, 3, and homework. Yeah. So these 4 assignments to prepare for the midterm. Okay. So then Tuesday, October 15th, Tuesday. So then you come here to do the midterm. Question?
Same time?